Hambini fans, and welcome to another episode of the Shite and Sarcasm Engineering Show, fronted by your favourite 5-year-old, that's me. In today's episode, we have, all the way from Taiwan, designed in the USA, this FUJI Transonic 1.1. I don't know why the hell they've put one in Word, a point, and then 1.1. Anyway, they could have saved some paint there. Right, to give you a bit of background, this bike was sent to me by a chap who bought a Hambini bottom bracket. This is the Hambini bottom bracket. It went in the bike and he'd had a few problems with it. So it's ended up here for a roasting. So without further ado, let me begin. So this is the FUJI Transonic. It is a 61cm frame. The chap who owns this frame, he's fitted Dura-Ace 175 millimeter cranks, and I think it's a 52 to 36. So I think it's a mild compact, whatever the fuck they're called these days. And a bit unusual for this sort of age bike, we've got metal dropouts, so metal dropouts on there and there. I don't know what the fork has got, and it's also got, if I just move this round, hopefully you can see, direct mount rim brakes. So as I said before, it is of carbon construction and it's got a Praxis works bottom bracket. Now the chap said he was having all sorts of problems with creaking, and that's why it's ended up here. So he also sent the bottom bracket that he originally purchased, which is one of mine, and he still said he had a problem. So the first thing to do with any of this, 90% of the history, 90% of the analysis is the case history. So we just need to take this apart and do a few other little checks. The first thing I've done is to check my bottom bracket was within specification. So I've taken a vernier to both planes, well, a micrometer, and unsurprisingly, they are within specification. So just to show you, it's supposed to be 46mm. There's a bit of inaccuracy in my vernier, but it is 46. To emphasise that I did use a micrometer on there, but I didn't show you because you wouldn't actually get a digital reading, but it is bang on 46. Now we can take the crankset out. Now the Praxis Works bottom bracket uses metal bearings, and what you can see is you can see the wear marks on the Shimano axle. So here it's worn quite a lot. If I turn it over to there, there's no wear. So, and you can just about see as I'm turning it round, the shiny mark develops. So that's when it's on load, which is what you would expect. You can also see this on the drive side, so it's shiny all the way around to there, and then when it gets to there, it's dull. It suggests there's a bit of ovality in there. Now the first thing I checked when I heard it was a Shimano crankset is to make sure that it hadn't done this, which is disbond itself. So that is my crankset that I've had, which a review of that and the failure mode of that is going to come up soon. But that is a very, very common failure mode, and creaking is a byproduct of that. On this one, what I did was I put it into a vise and then twisted it on here and here just to make sure that it wasn't flexing. You'll see when this one is reviewed how I established that it was having a problem. So the crankset here is fine. Back onto the bike frame. So on the Praxis bottom bracket, these things, they're just rubber seals. So there's two of them, one on each side. Behind there, you've got Enduro steel bearings. They are MR2437, and they use NTN's seal prefixes, so the LLB. What we need to do is we need to get this apart. Now, in order to get this apart, what I've been using in the past was the Park Tool BBT9, but I got a bit annoyed with that because it kept on shredding bits, so I decided to make my own. The difference is this is, I think it's stamped. Looking at the markings on the back, and this is machined, so it gives a bit better bite. So we'll take it out using one of these. Now, on here, there's a side that says tighten, and this one says do not turn, so we'll go with that. So we'll get the, I've named this the 6806 tool, 6805 tool, whichever, anyway. Right, we'll just hold this one with that. Now it comes. So in here there's also what looks like an EPDM seal. We'll come to what that is in a minute. The next thing we need to do is we need to fish this side out. In order to fish that side out, we're going to have to tap through here and then pop it out. So let's do that. What I've got is I've got a 30mm DIN size socket. Probably shouldn't be using this for this. I'm going to put it into the bottom bracket and tap it with a soft blow mallet. And out it comes. So we're not on my tripod at the moment, but what you can see in here is part of the bottom bracket, which is this plastic sleeve that moves. You can also see it's crushed halfway down. So we need to fish that out now, and then we can do a bit more of the case history. So what I've done is I've got it like most of the way out, and you can see a bulge, hopefully. That isn't supposed to be there, but we'll fish this out and then we'll explain what's happened. So what you're looking at now is the drive side bottom bracket. You can see a huge chunk missing around there, and also around all the way around the periphery there's large areas of material, so it's not very good compression around there. It's the same here. Now when we go inside to do the PowerPoint, I'll show you those in a bit more detail. So this is the non-drive side of the bike, and I've got my ball mic in there. You can see it's at 46.05, so the limit value is 45 well, it's 46mm, so it's way beyond that. And this is the drive side, and that is 46.02, 03. So again, it's way beyond spec. So this is the Praxis Works bottom bracket. Now, to explain how this works, I'll show you the few bits that came with it. It's effectively in a few pieces. Now, this is designed for BB30 and PF30. So if you're using PF30, you need to have this in. So this, we'll come on to what that does in a second. How this works is quite clever, really. You've got one side that's fixed, which is this side. So you press that into the bike frame, and then this screws in. So it's basically a thread together bottom bracket with a key difference, and that key difference is this orange thing, which is basically like a glorified rubber washer. So as you turn it, these two faces clamp together and then squeeze that rubber, I think it's EPDM, outwards, so it starts to get bigger, and then that bites into here and the whole thing grips. Now the problem is, if you've got a shell that is oversized, which is what we have on this bike frame, you end up putting too much compression onto there, and it actually crushes this, and that is what's happened. So that has squished. So you've got too much clamping load there because that hasn't expanded enough, and that's crushed. So everything fits together. So that's why we've got the failure that we have. Here we go again. It's that time of the show. It is time for PowerPoint. So, should we do the pen is working first? Let's do the pen is working first. Is the pen working? Pen is working! Now, if you're not a regular viewer to the channel, you might not know what all that is about, so you need to go back through the back catalogue and have a look at it. Right. FUJI Transonic I'd rather take a shower in petrol and then smoke a firework. As I am a chain smoker, I know all about smoking, especially smoking petrol. By Hambini, age 5, and a new addition to my title slide. I'm now on Patreon. I'm not quite sure how it works. I've set it all up, but it's asked for membership levels and all that kind of thing. I don't really understand that, so I might have to ask someone who does how that works. Right, next one. First step, the bike is called the FUJI Transonic. Transonic is high drag. There's like drag and transonic drag. In fact, a transonic drag, you get more drag than a supersonic drag most of the time anyway. Total wanketeering fail. Anyway, we digress about that. Firstly, the chap had creak before the Hambini BB, after the Hambini BB, and the Hambini BB ended up being loose. So, there's a problem there. Bike frame is a PF30, a bottom bracket, and he tried multiple units. Finally tried that Praxis, and he sent it to here. Right, Fuji is a bike manufacturer. They have, I think it's 120 plus years of making bikes. Started off as an importer and into all that, all this, that and the other. I had a look on the Wikipedia page, shows bankruptcy, sales, acquisitions and all that kind of good stuff. Right, the frame internals. Now some of you are quite interested in all of this stuff. Right, inside it is actually quite clean. If you forget all of this stuff over here, that's just dirt. So forget that. It's because it's a used frame, and some of these lines are me shoving my doobie what's it up and down. Again, you know, there's another shot, and you get the usual excess adhesive. That's not resin. That is where two parts are glued together, and there's a bit of a difference there. I suppose you could say it's epoxy resin. Well, whatever. Anyway, there's a bit of overrun there, and again another shot on the insides. The headset, now another place to look, which is a lot more obvious, is the headset, and what you're looking for there is whether it's a round and whether it's compacted well, because the headsets, if you were to draw a section through here, right, they look like that, so the corners are dished. Usually at 45 degrees. Oh god, I haven't drawn that very well, have I? And then the bearing sits something like that. Okay, so you have this little chamfer in here. And the chamfer that exists there to increase the preload, because the bearings are effectively angular contact bearings. There's like a 7000 series bearings. But yeah, I mean that, well made. I mean, the bike is almost like it's in two halves. You've got the rest of the bike frame, which is really, really clean, and then the bottom bracket, it's like it's been made by somebody else. This is the bottom bracket, and it probably didn't show up that well in the video footage, but you could see quite clearly there's chunks missing. This yellow stuff is retaining compound, so you know, don't read too much into there. And you can just about make out here, but you'll see a better shot in a minute. It's a bit scabby around the edges. This is another shot of the bottom bracket. It's a lot more obvious here. Now, if you look at this pair of arrows down here and this pair of arrows up here, you can quite clearly see the thickness difference between the two. You know, that is, what, a few millimeters? And then over here, it's considerably thicker. And it's also not round. I mean, you see that bit there, whoops, here is almost flat, and that's nicely curved. And you tend to get the things coming together. As I mentioned before, the scabby bit, I mean, look at this. Now, a few weeks ago we had the ICANN frame on here, which was the grand sum of $730 or something like that, and they'd gone to town with it. And since that video was made, other people have bought that frame, and they said, you know, the frame, they did a light test basically, and yeah, it came out with flying colours, so it probably wasn't a Hambini special as some people speculated.
This is the readings. So this is the readings of the, I can't remember if this is the drive side or the non-drive side, but basically it's oversized. The non-drive side was a bigger diameter than the drive side, but it was still beyond spec. So the limit is 46 millimeters. If you do 46 over 2, you get 23. So that's where this comes on. So that's your limit line there, limit ring. If you follow that all the way around, so that's where it should be. Now it may be a little bit misrepresentative because there's not much in the scale. So you know, what one line's, that line there is 06, and that line I've actually drawn it on the wrong one. Sorry, that's the 23-minute limit line. Got that a bit wrong. Never mind. At least I was recording it live. Yeah, I mean that's your range that you can go in. Sorry, that's the limit line. So a typical range will be between this red line and that red line. So 1, 2, 3 red hoop or 3 hoops would be a tolerance range. But the ICANN frame, and you're going to see it shortly in a few weeks, maybe not even a few weeks, the wind space frame are well within that range. The other one, which is a lot more telling, and you'll see it in the next slide, is the axial runout. So I actually did this wrong because I put the datum point in wrong. So it says 43.2. That should actually be 34. Which is half of 68, but because I'm dyslexic, I got the numbers the wrong way around. Anyway, if you forget that and actually look at the delta, what you're looking for is a straight line. So what we're doing is if I go back to this slide, is we're putting a clock on here and then going all the way around. So it's your face measurement. Face measurement should be 0, basically, no deviation. There's a big deviation between the highest point and the lowest point. It's basically not flat. Now, if you look hard enough, and you've just seen the video footage, you can actually make this out in the video footage. So if you look here, see there's a small gap there. If you zoom in, it's quite obvious that it's not flat. Right. Face runout, that level of face runout makes it actually quite difficult to map the misalignment, but the two sides were misaligned, so I didn't bother doing it. Right, the best fix is to buy a new frame. The next thing to do is to insert it from the non-drive side, because PF30 is symmetrical. You can do it from both sides. Offset the interface landings, and now some people might be wondering why I've chosen not to face this, and that is the carbon in that area around the bottom bracket. So let's go back. Yeah, carbon around here is, to put it mildly, somewhat ropey. So you need to take that engineering decision of whether you're gonna sort of potentially open a can of worms or not. So this is a normal bottom bracket. It's perfectly concentric, so the center line is through there, so everything goes off that center line. On this bottom bracket, you have to do something called an offset. So because the two halves are not concentric with each other, you make one the datum. So it doesn't actually matter which one you make the datum. Probably this, for argument's sake, because it's a schematic, the blue one, and then you offset the red one. But the center line of the bearing landing remains the same. So it's exaggerated, but that's where we're going. Right, that is enough of me blabbering on. Let's go back and fix this damn thing. So now is the time to fit the bottom bracket. So this is the bottom bracket that has been made. You can see, hopefully, 2 black lines, which are the index marks. Now on a normal bottom bracket of mine, they usually come in from the drive side. But on this one, because this side is bigger than this side, we're going to come in from the
non-drive side. It doesn't actually matter because PF30 is symmetrical. First step is to clean it. I've done that. Now we're going to spray it with some activator. So 7471, there's also some others, 7469 as well. Let that dry and then wipe the excess off. So now we can put this in. So we've got the bottom bracket lined up, put the press adapter in, line this up into the bike. Then we need to put a bit more thread through and lock it up. So we can just now thread this up. So it's gone in halfway. Get it to there and now put some retaining compound on. Now we'll just tighten it up the rest of the way. And there we go, we're finished. What is quite astonishing and noticeable with this is how not flat this surface is. Now I did mention it before, but this is a 0.3 millimeter feeler gauge. So around here, you know, it's flush. As you get down here, that's incredible. To be honest, that's dreadful. Now we can put the bearings in. Unlubricated, of course, to cause controversy. We can now put the crank in. Put the preload collar on. Way! That'll do me. That's alright. And now time to give it a spin. There we go. Now we just need to make sure this is rigidly in. And it is. Now I'm hoping that you can see how big the gap is underneath there. It is just ridiculous, absolutely ridiculous. I can't believe that's been let out the bike factory like that. And then up here, there's no gap. Now normally, I'd go for facing that, but I'm not confident in the carbon. And that brings us to the end of this video. I really hope you enjoyed it. If there's something to learn from it, it is, well, I don't know. I mean, the rest of the bike was pretty good, but that bottom bracket was a bit of a shocker. So what can you do with that? As always, remember to smash that like button, whack subscribe, and keep banging your hairdresser.